Alright guys, today we will discuss the wardley mapping, right? So let's start how we can do it. So what is wardley mapping, right? So first we will discuss what is strategy, right? We will build the ground from here. And okay, so let me tell you about a CEO who had no idea about what he is doing, right? Like there is a CEO, right, of a company. His company is profitable and revenue was growing, right? People respected him, and yet every time he had to make a strategic decision, like where to invest, what to build, what to outsource. There, he was just making things up, like grabbing impressive sound words, like reading every business book, getting nowhere. So it will not get him because he doesn't know how its thing is working, right? So that CEO was Simon Wardley, right? And his frustration led him to invent one of the most powerful strategic tools in business, the Wardley map. Okay. So in the next few minutes, in this tutorial ahead, uh, we will go from what it is to being able to draw, read, and use a Wardley map on a real problem, right? No MBA required in this. So let's go. Sun Tzu, if you haven't heard of him, this is a very famous uh, writer, like Sun Tzu. If you haven't done the connection, what is Sun Tzu? So there is a connection with Sun Tzu and Wardley. There is a connection. What was the connection? In 2005, Wardley discovered something crucial by reading Sun Tzu's Arts of War. So he wrote a book called Arts of War, right? So in this Arts of War book, Sun Tzu identified 5 factors that matter in competition. What are those 5 factors? One is purpose, two is landscape, right? Third is climate, fourth is doctrine, and fifth is leadership. These 5 factors matter in a war. Who identified it? Sun Tzu, right? From this, there was a writer in America, I think, US Air Force, right, who gave OODA trap, OODA loop. right? How it is connected with this. Purpose is like why we are doing this. Bias, right? Bias of us. Why we are doing something. Why we are fighting this war and all, right? Landscape is observers. We have to observe the landscape. We have to observe the things, right? What's changing, what is a pattern like that. This is also climate and all. This is both are observed. Then we have doctrine, which is orient. Observe, orient. Right? Orient means how we are going to do these things. And leadership is decide plus act. Leadership will decide and act. So this will map to OODA loop, right? This OODA loop. So this will map to wardley map. How this will map to wardley map? This is like why we are, what is the purpose? Why we are building this business, right? Then observe climate patterns. Then doctrine we have. And landscape is the map itself, right? The map itself is the landscape here. Okay. Doctrine, like we have also doctrine like how we will do things. Then the gameplay. We will discuss these one by one. Okay. So, at the heart of both frameworks, right? Why? Why is the question? Why we are doing this? Why make this choice over that one, right? Why this is superior to other? So strategy, we make strategies like this, but strategy without knowing your landscape is just guessing, right? This was like little introduction. Let's go further from here. We have maps versus graphs. We have maps versus graph. What is a map and what is a graph? Let me understand this. Before we draw a single wardley map, right? I need to destroy something most business call a strategy map. When Simon asked his team for their maps, right? They sent him mind maps, system diagrams, organization charts to him, right? He took one end, a system diagram with a component called CRM, and he moved CRM across the screen. Then he asked, how has the map changed? Answer, it hadn't. So the same nodes, same connection, nothing changed. He realized this is not a map, there is a graph. So let's take this example here. If we have some map, like and this map has some components. Okay. Let me tell you, more specifically, okay. Okay. Let me tell you something. graph versus map. Okay, let me tell you something. Okay, just map for wardley map. Yeah, this is a interesting photo, I think. So, what happens is, let me take this here. Very nice. Very nice. So, like, so what is the difference between graph and map? So, this, let's say this is graph. This is one node, this is one node, and this one node. If I move this here, over, there is no change here. Like, if I, so there is no concept of space in graphs, right? If I move like this to like this here, right? So this is same graph, but in maps there is a concept of space. If I move Dover here, now the distance between London and Dover has changed, and road is also changed, right? On map, like, let's say this is India, right? This is India here, and this is Australia here. So if I move Australia from here to here and move China from here to here, so whole things changed, right? Everything changed between, the whole map changed. So if we move things in map, the map will change. But in graph, if we move things here and there, graph will not change. Correct? This is the difference. So what we do, we will build the map, not the graph. Move any component and get map, everything will change. Position define the meaning there. Like, space will carry the strategic information. So let's say we have this this is one box, this is two second box, right? So this is 1, 2, 3. These are all connected. Okay. This is CRM, this is email, this is DB, right? So if I move CRM from here to here, did anything change? And but if I make like CRM here and email here, like this, right? And we have X and Y axis. This is X axis, this is Y axis here. If I move CRM from here to here, right? Now things change, because this Y value and X value was telling some value, space and time. So this is space, right? So in this graph, map has changed. So map has the space with meaning. Moving a piece on a map changes what that piece means. A graph is just nodes and edges. In that case, rearranging it tells you nothing new, right? Okay. Anatomy of a wardley map. Let's understand this. Anatomy of a wardley map. Every wardley map has three ingredients: an anchor, and position, and movement. One is anchor, one is position, and third is movement. So these position, any geographical map has also position. Geographical maps have movements, and anchor are also like directions like north, south, where we are going, right? So in geographic map, your anchor is a like magnetic north, right? Like for example, magnetic north. In wardley map, your anchor is a user. So user is our anchor because we want to deliver to a user, right? The person whose need you are trying to serve. Okay. So let me like draw a blank canvas for wardley map, how it looks, right? Draw a row, draw a line, okay. This is a line here. Alright. Alright, so one thing is like first this is things are invisible here. I will explain this why this is invisible. And this is like this axis tells us value chain, or we can select visibility. Okay, and this axis tells us the evolution, right? Now in this we have some phases. First phase is, let me draw a line with okay. So one is genesis. Then second phase is what happened now? This is custom built, and third is product, and fourth is the commodity. So I will explain some things. Let me explain like more things like. So anchor the user, right? User is will be always at the top. Why? User. Visibility of user is the most important. User is visible to everyone, right? The anchor. Okay. And without a clear anchor, you have no preference point, right? And second is the position. Each component placed relative to the user y axis, right? This is y axis. This is x axis. So each component placed relative to the user, which is y axis, and relative to how evolved it is, x axis. Genesis to community. This is the position, right? So position we will find like if here, if it is here, if it is here, like that. And movement, component evolve from left to right. Okay, this is the evolution. Component will evolve from left to right. Okay, this is the movement in this map. This is not optional. It is driven by supply and demand competition. Let me explain you. Okay. So there is a 4 stages of evolution, right? Now in the horizontal axis of evolution is a beating heart of wardley mapping. Every single component in a business, whether it's a technology, whether it's a practice, we do like things with in certain manner, or a process, moves through 4 stages. Everything. And knowing which stage something is at tells you exactly how to manage it. Okay? If that technology is here, if that technology here, here or there and here, wherever it is, it will tell us how to manage it. Think about computing. In 1943, a computer was a hand-built research device, right? So this was the genesis. Okay. Compute in 1943. This was the genesis, because we were modifying that too much. So let me tell you one thing more also. What this is, then you can relate more. Genesis is like, it's a chaotic, uncertain, and exciting new. Like we make lot of changes and frequently in this. Okay, at this genesis stage, and this is standardized, predictable, and boring. So when compute was discussed in 1943, it was at genesis stage. It's what chaotic, uncertain, how we will use it and how is this important or not, like why we are doing this. Okay. There was a hand-built research device. Then, by the 1970s, companies like IBM were selling standardized product of it, right? So it was a product computing, like computers were a computer was sold out, right? Today, you rent a computer by a second from AWS community, right? So these same evolution happens to everything. So genesis are novels, rare, like poorly understood experiments, right? It has high risk, high potential reward also. For example, AI in 2012, right? Blockchain in 2015, the first cloud service in 26, electricity in 1800s. They all were geniuses at that time, right? So, these were managed. These were agile. Okay, explore this. This is the. These were the categories for them. But after that, we this evolved from this to custom built. What is this? When understanding grow, okay, we have consultant everywhere to consult with them, like mobile apps in 2009. Okay, we have to learn those tools. Consult. There is a supervisors to them, right? There are supervisors. So this is like learning phase, like learn, lean, scrum, like this. We go for this then. After that we have product part, product oriented. Like after learning and we have products, standard products, sold as products like vendor ecosystem here, right? Well understood and documented. Like CRM software by Salesforce, email, Outlook. These are in 2000s, right? So these are uh, managed with Six Sigma, or we can say ITIL. Then we come for the last part, commodity. This is like standardized, interchangeable, consumed like a utility. Okay. This will be compete on price and reliability. So like these are things are we outsource them. Okay. I will discuss it later also. So we go from uncertain, okay, we go from here to learning and building, right? After that we go for standardizing and scaling. After that we go for reliable, efficient. Okay. Anyways, so the agile trap. There is agile trap in this. We talked about agility here, right? So okay. So we talk about agility, right? Let me. Well, so this is agility. So there is agile trap. Simon Wardley insight is that being agile means using appropriate method for each stage. This is called being agile. It's very different from using agile. So being agile is very different from using agile. What is being agile? Being agile is how we use appropriate methods for each stage, right? But using agile is applying learning, right? Experience everywhere. Applying Six Sigma of a Genesis stage. Applying Six Sigma of Genesis stage, like Genesis stage is catastrophic. Applying agile to commodity is wasteful. So match the method to evolution stage. Okay. So how to build a first Wardley map? So let's build our first Wardley map together. We will use Simon's original example, a tea shop. Okay, it's simple enough to learn from, rich enough to teach application. So who is the user? Person who wants to drink tea is the user, right? Step 2. What do they need? We have a user want to drink tea. What is the step 2? What they do need? They need cup of tea. Okay, this is a cup of tea. Let's make it more. Okay. Now, step 3 is what does that cup of tea need? This cup of tea need milk. This need water also. Right? So, this need leaves of tea. Leaves of tea needs water, hot water, right? Hot water. Uh, we need kettle for this. For kettle, we also need water for this, right? And we need power. User just need this tea, right? Then so this is the visibility. Okay, so if we want to draw this like this, user is always on the top, right? User is. We have cup of tea. Okay, we need leaves, tea leaves, and we need hot water. We need cold water also for hot water. We need a kettle and we need electricity. When a user wants tea, this axis was visibility, right? So user only sees the cup of tea, but electricity is not visible to him. He will never think about how this how this power, how this cup of tea used power, right? And now we will add evolution to it. So now we ask for each component, right? How evolved it is. Is electricity a custom built novelty? No, because it's a commodity. You plug it and it works. It's a very standardized thing, right? So where we put electricity in this map? Okay. Let me here. Okay. Where is electricity here? Electricity is here because we are not changing things, right? Electricity is already developed. You plug it and you use it. It's a commodity to us. Predictable, right? Standardized. What about a specialty tea blend, right? That might be more towards like custom because not every tea shop has the same blend. So what about kettle? So what I am saying, tea leaves are like here. We are we can use different tea leaves, right? Like this. Okay. This is electricity to us. And what about kettle? I think kettle is also commodity, right? because it's already available. Kettle. Okay. And where you put cup of tea. Cup of tea is the product, right? We are trying to sell that. Cup of tea. We are scaling it. What is hot water? Hot water is also there, but in this range. Hot water is also product. Okay, we have some cup. Where you find cup? Cup we can find anywhere. Cold water is everywhere, right? Cold water is everywhere. Kettle is everywhere. Okay, cup is everywhere. Now, if we like this, how we get this hot water? Let me draw some very special lines. Okay. Let me raise this. What? Okay. Alright. We have hot water. We have hot water. We have cold water. Okay. We have cup. So, what cup of tea need? Cup of tea need a cup. It needs a hot water. Hot water needs a kettle and cold water, and kettle needs the electricity. Okay. This is how tea leaves is there here, and customer needs this. Okay. So what is this map trying to say? We can outsource these things. We can get cup from anywhere. We can get cold water from anywhere. We can get kettle from anywhere. We can get electricity from anywhere. How? This is the product. Cold hot water and just cup of tea we are building. Tea leaves we have to customize, right? We can change these things. So what this example is trying to say, if we change cups, if we put cup here and we change cups daily, right? It will cost us more. It will be inefficient. Okay. If we change kettle, because this is Genesis and customer like changing things, right? If we put kettle here, right? Kettle, if we change kettle daily, so it will be impatient and costly also. Electricity, if we change source of electricity daily, so this is not. These things are standardized. We use them, right? Utility company, okay? So this is the power of map. It shows where you to invest, where is just buy. So you have to invest here. You have to get different types of tea leaves, right? Okay. So just you don't need to make this cup of coffee, kettle. You can just buy them. Okay. And real world map, that revolution of cloud computing. Now let's apply this to a real business decision that changes history, right? So it's 2006. Let's say you are running a canonical the company behind Ubuntu Linux. Okay, you are 2-3% of the server OS market, competing with Microsoft and Red Hat. How do you become number one after this? Simon Bradley drew this exact map and it told him something most people couldn't see. The entire computing landscape was about to flip. Here's what maps look like. Okay, this was the map. Uh, okay, this was the map here. Okay, this is invisible. Here is visibility. Okay, so Ubuntu was created. What user needs, right? What user needed? User needed a application. Okay, so what this application needed? It's needed a runtime, right? Like NET or LAMP. This needed the OS, Linux or Windows. Okay, this needed the compute. Okay, compute by available by the AWS EC2, launched in 2006, right? It's a cloud utility. Okay, and application need the coding, so best coding practices. Okay, and runtime needs what? Best architecture practices. We can modify them a little, right? So this is the Genesis part, this is the custom built part. Okay, and this is the product part. Alright, and this is the commodity part. So compute is, so in 2000 in 1943 compute was in Genesis, right? Now compute has evaluated to community part. Okay, so that's not a speculation, it's a pattern. Everything that can be commoditized will be commoditized. Okay, and this is not the question will it be, it will be. The question is just when it will be. If there is a thing can be commoditized, it will be surely commoditized. Okay, if compute becomes a utility. Okay, here utility, what changes here? Everything built on top of it changes too, because the architectural practices you had for custom servers, right? Like M+1 redundancy. What is M+1 redundancy? Like disaster recovery drills and capacity planning, right? Like how if a server fails, how much time it will take us to get the new one and all, right? If we can have this server on remote access with AWS, right, as a utility. So then if we don't have to buy new, we can just connect to new, right? So those becomes those disaster recovery rails and M+1 redundancy planning, those practices becomes unnecessary. Then new practices will emerge. We call them like DevOps now because we have cloud, right? So canonical bet. If cloud is the future, okay, the OS that wins cloud wins the market. with whoever the OS wins the cloud, it will win the market. They focus entirely here. Ubuntu, right? Ubuntu. So, what Ubuntu did? In 18 months, from 2-3% in the market, they becomes 70% of the market of all cloud computing runs on Ubuntu. Okay. So in 1943, in Genesis, right, first programmable digital computer was discussed and built unique and experimental, right? And in 1955, it goes to custom builds. First commercial computer was Leo, was introduced. It was custom made for each organization. Then in 1964, it moved to product by IBM System 360. So it was a standardized, sold as products, right? Vendor ecosystem begins, right? And in 2006, the commodity has began. Amazon EC2 compute as a utility, pay per hour like that. New practices emerged like DevOps. And 2014, new Genesis happened like serverless. AWS Lambda runtime become a utility, serverless error begins. Okay, evolution never stops because now AI is Genesis stage. Foundation models like currently custom built models, right, will become commodity one day. These will become DevOps equivalent, will emerge MLOps. Okay, like that. So whatever the Genesis stage today will be a community in 10 to 20 years. If you know this, you can position yourself for the next transition. The question is never if, only when. Okay. So 3 types of patterns are there. Let me explain this. 3 types of patterns. So once you can draw maps, you can start to notice patterns in the maps. These patterns come from studying many maps over time. Okay. So pre-mortem is a stage before a project and a post-mortem after the project. So Simon identified 3 categories of patterns. One pattern is climatic pattern. Okay. So things you cannot control, caused by supply and demand. Okay. So evaluation will happen whether you want it to or not, but you can anticipate them. Okay. Second is the doctrine. So things you should always do is, this is the doctrine. The things you should always do, regardless of the context, universal best practices like that. They won't hurt you, and ignoring them will hurt you for sure. And for climate, there are 30 known climatic patterns you can't control. This based on supply and demand. Doctrine is things you should always do. And after this we have the gameplay. What is gameplay? Context specific moves, like it will depend on the map, like on where your component are and where competitors are. So it is not universal, only work in a specific position. Gameplay is there. So observe your context and play the move. Okay. Okay, let's discuss anticipation. Okay, so anticipation is related to climatic pattern. Anti-climatic pattern is like climatic patterns are the thing you cannot stop, okay, but you can predict them. Like the weather, you cannot stop rain, but you can check the forecast and bring the umbrella, right? Here is the most important once you know, because everything evolves, right? You can predict that everything evolves. You cannot stop it. If there is a supply and demand competition, everything moves from genesis to commodity. Okay, there is no if only. There is no if in here. Only when. When it will move from genesis to commodity. Like computing, like AI, like electricity, like railways, all of it had moved from genesis to commodity, right? So, what is the strategic implications of it? Whatever you treat as a bespoke advantage today, it will become a commodity your competitors can buy, okay, off the shelf. Plan for it, okay. So, you can predict like if there is a something we are building, it can become commodity tomorrow. So, should we invest here or no? Okay. Then we have inertia. When something evolves, right? Companies with investment in old form resist to change, right? But Blockbuster had more technical capability than Netflix, but had inertia, like store leases, existing models. Kodak invented a digital camera but had inertia, film revenue. Okay, so what is the strategic implication? When you see inertia in a competitor, you see opportunity. They are slow to adapt, attack here. So inertia is like old company has some patterns like they just follow those patterns. What you can do, you can like revolutionize the process. If they are slow to change and slow to adapt, this is their inertia. You can attack there. Third is co-evolution of practices. When a component evolves, right, the practices around it changes too. Okay. The compute going from product to utility made capacity planning obsolete because and created DevOps. AI going from custom to community will obsolete current ML workflows and create new practices, probably called something like model ops or AI DevOps. Okay. Like compute as a product, high MTTR, and as a cloud, low MTTR seconds and API call is a new machine. But new practices are designed for failure, chaos engineering, led predictions like that. Okay. The red queen effect. Okay. Red queen effect. What is this? This is named after Lewis Carroll. It takes all running you can do to keep the same place. Okay. When a product component is commoditized, it creates efficient speed and new value for those who adopt it. Okay. Those who don't adapt feel increasing pressure as more computers to adapt. Okay. The pressure is itself reinforcing. Cloud was never a question of if, only when. So the red queen effect is like if there is a product becomes community, right? It creates efficient speed and new values for those who adopt it, right? If you don't adopt it, and your competitors adopt it, you will feel the pressure. You have to adopt. This is not, there is no question of if, they only when you adopt it. So draw the compute timeline. Okay, you there is a, you understand the anticipation of climate pattern. Now let's understand the doctrine. What is doctrine? Doctrine is the universal principle. Okay, what it is? Doctrine is what you should do regardless of the context. Okay, think of it as business hygiene. Like there are the principles that come from studying hundreds of maps across many industries, right? So let me give you the core seven, the ones that appear in every successful organization. These are the universal principles. Principle one: focus on user needs. Okay, always start with the user. Who are they? What do they actually need? Not what you think they need, what they genuinely require. Focus on that. Principle 2: understand the component. Okay, know what you are building. Map every dependency. Surprises in supply chain kill the project. Okay, you should know everything. Know their evaluation stage. Okay, you have to know that. For each component, know if it is Genesis, its custom, product, or community. This determines how you manage and fund it, right? 4. Use a common language. Alright? So, maps will create a shared visual language. They let you challenge others' assumptions without attacking their narrative, right? Can we just map this? Is the magic question. Okay, map is a common language. You can make understand everything with that. Then we have this use appropriate methods. Okay, agile is the method for Genesis or custom, like, okay, lean or scrum is the middle ground. Okay, and Six Sigma outsourcing for community. If it is mismatched, they waste error to cache or traffic. So for every stage, like if the component is at Genesis stage, then we should be agile. If it is at product stage, then we should be Six Sigma rule. If it is at custom build, so we should use the learning and what we say, Scrum method, right? After that we have remove bias and duplication. What does this mean? Across multiple maps, right? Look for the same component being built twice. Once a community, once a custom, standardized. Okay, you are probably rebuilding something you could share. So you have to look into that. You can share that. And next is have a bias towards data, like use maps as data. So run pre-mortem challenge before building, right? And post-mortem learn after. Maps are living documents, so keep updating them. Okay, then we have challenge assumptions. Okay, a map makes assumptions visible. Alright, so the most valuable map is one where you see something and it something on it and ask, wait, why is that there? The insurance company will customer track. Okay. Okay, guys. So now let's come for gameplay. Okay. Third pattern, which is gameplay. These are the strategic patterns, right? What is gameplay? Gameplay is innovate. Innovate, leverage, and commoditize. We have covered the ground rules. Now let's talk about how to win. Okay. Specifically, one of the most powerful gameplay moves in the wardley playbook. Okay. It used at the scale of Amazon, Google, and even national governments. And once you see it, you will see it everywhere. The model is called Innovate, Leverage, and Commoditize. ILC. Innovate, Leverage, and Commoditize. This is the gameplay. What is innovate? Take something at product stage, turn it into a utility. Okay. Expose it as an API, enable others to build on top of it. Okay. For example, Amazon takes compute and builds EC2 top of it. What is leverage? Leverage is watch what others builds on your platform. They are your free R&D lab. Mine the data, metadata from them. What are people actually building? For example watches, Amazon watches big data, ML, Qs, CDN, ML, or leverage on that. And then community. Take the pattern you spotted and offer them new component services. Fast and cheaper. Anyone else can build. Okay. So Amazon launches S3 and SageMaker and services. So here is a beautiful part. As a platform grows, your apparent rate of innovation increases with ecosystem size, right? The bigger the ecosystem, the more data you have. The more patterns you spot, the more services you can offer. The more people join the ecosystem. It's a flywheel. Okay. Jeff Bezos figured this out. Simon Wardley wrote about it in 2005. Most companies only discovered it after the fact, when AWS had already won. Okay. So I innovate, leverage, and commoditize flywheel. Why Amazon keeps winning like that? Big data, MLOps, and like that. Okay. If you are competing against anyone using the ILC like model, Amazon, Google, Salesforce, you need to understand this playbook. If you are building a startup, you can use a smaller version of this. Build the platform, let your customer extend it, and watch what they build, or productize the best ideas. Okay. Okay, thank you guys. This was from my side, and we will meet you to next lecture.